Hi student, welcome to chemistry class. My name is Olusola Adiola, your chemistry teacher. This video is brought to you by Gotha Virtual Learning, and in today's class we are going to be looking at the periodic table. In the last video we have looked at the development of the periodic table. We've looked at the modern periodic table and Mendel's periodic table. We have looked at the new periodic table arranged by Mosley, and of course the properties of this periodic table, having periods and of course groups, and how the elements are classified. We looked at the periodic law, and then I also look at how the periodic table is organized, the properties of key different types of elements in the periodic table, and then we have also looked at the important properties of each group, each specific group in the periodic table. So in today's discussion, we are looking at the periodic trends. We are looking at the periodic trends. So and in this trends today, we are going to be looking at the atomic size. We are going to be looking at the ionization energy, electronegativity, electron affinity, the metallic character, and some other ones. Now let's start with the atomic size. The atomic size of an element is usually expressed as an atomic radius measured in picometers. And what is atomic radius? Atomic radius is equal to half the distance between the nuclei of two atoms of the same element when they are joined. In the diagram here, you observe that you have two elements, most especially diatomic elements. For instance, hydrogen, oxygen, nitrogen, and the noble gases. They are all diatomic elements. Now, each of them have two atoms each. So the atomic radius measures the distance between the nucleus of the two atoms. And if you look at this video, we have the one with the lowest atomic radius is nitrogen, having 30 picometers. Oxygen is 68, nitrogen 70. And then more interestingly, if you look at the halogens, starting from fluorine, it is increasing from fluorine to chlorine, bromine, and iodine. So what that means is that atomic size will increase as you move down the group. The atomic size will increase as you can see. Fluorine is the first member of that group, and the atomic size, now measured in terms of atomic radius, is increasing as you are moving from fluorine to chlorine, bromine, and iodine. Now, across the period, the atomic size is decreasing as you move from left to right across the period. Now, to state why atomic size will increase down the group, you observe that as you are moving down the group, the energy level of electron is also increasing. The energy level, for instance, hydrogen is placed in group 1 and then is in period 1. When you get to sodium, you are going to have two shells. That means that from one shell to two shells. When you move to potassium, you are going to have, when you move to lithium is 2 shells, sodium is 3 shells. When you move to potassium, you have 4 shells. The number of shells is increasing down the group. So what does this mean? As a result, two things will be affected. Number one, the weight of the atom will increase because the number of shells is increasing. Additionally, what happens is that there will be what is called the screening effect. The lower energy, for instance, if you are doing the electronic configuration diagram of potassium, for instance, you are going to have 2881. So the valence electron is 1, which is at the fourth shell. Now the inner electrons like the 288 will shield the outer electrons from having interaction with the nucleus, because the more they move further from the nucleus, the lesser the nuclear interaction or effective nuclear charge. So as a result of this, the positive charge will pull the lower energy level shield the outer energy level from the positive charge, which is the nucleus, and of course they will not allow you to pull towards the nucleus. So the shielding or the screening effect of the inner electrons by the outer electrons, and of course will cause the atomic size to increase. So generally, let me give a rewind. Atomic size in form of atomic radius now we increase um, we increase down the group because of the screening effect, and then we increase across the period because of the screening effect as well. The screening effect ensures that atoms get further, um, the atoms that are getting further are shielded from the inner electrons. Okay, so quickly we move to another ones. Um, uh, Another property of the periodic table, the ionization energy. The ionization energy is energy required to remove an electron from an atom. The energy required to remove an electron from an atom. Now, for ionization energy, we have the first, second, and the third ionization energy. For instance, if an atom has 3 valence electrons, to remove one is first ionization energy. If you remove the second one, second ionization energy. If you remove the third one, you have the third ionization energy. This one is common to group 3 that have first, second, third ionization energy. Group 2 we have 2 because we remove 1 and 2 respectively. Now, if you have higher ionization energy, it means that the electrons are going to be very hard to remove, and then they are likely less to form that ion. They are likely less to form that ion, and that is what is unique about group 1, 2, 3. They have group 1 has 1 valence electron, I will form 1 ion, positive ion. Group 2, 2 valence electron, positive ion. Then group 3, 3 valence electron, positive 3 plus positive charge. Now, because of the higher ionization energy, that is why group 2, group 4, group 5 mostly do not have you have more than one oxidation state, because they are less, because they are harder to remove, they are less likely to form that particular ion. So to explain the trends of the ionization energy, the ionization energy will increase across a period due to effective nuclear charge. The ionization energy will increase across a period due to effective nuclear charge. Don't forget that ionization energy is energy required to remove an electron. Now, when you check group 1, 2, 3, which are more of metals, the metals lose electron easily. So as a result, the ease at which they lose electron require less energy. So they require less energy to donate their electron. And also know that as you are moving across down the group, metallic property increases or electropositivity increases. So therefore, the ionization energy will decrease. And another way to explain the ionization energy decreasing down the group is the screening effect. As you are moving down the group, the screening effect is getting increasing. As you are moving down the group, the screening effect or the shading effect is increasing. So therefore, the ionization energy will increase. It will be easier to remove electron. Why? Because the interaction between the outer electrons and the nucleus, they are far apart. So there is no nuclear interaction. There is no nuclear. The effective nuclear charge is small. So it will be easier to remove electron from them. But as you move down across the period, ionization energy will increase. Why? Because it will be very difficult to you to remove an electron due to the effective nuclear charge. There is a lot of interaction between the nucleus and the surrounding electrons. So the nuclear charge would have increased. So removing electrons will be very difficult. So energy required will be high. So down the group, it is increasing. It's decreasing, and across the period, it is increasing for ionization energy. So let's look at electron affinity. Electron affinity is energy that is released when an electron is added, or is also the ability to accept electron. Now, down the group, ionization energy will decrease, while across the period, ionization energy will increase. Now, let's look at uh, another one, which is the ionic radius or ionic size. As atoms lose electrons to become cations, the electron clouds become smaller. The electron clouds become smaller, and then of course, the nucleus pull harder on the remaining electrons. But as atoms gain more electrons, as atom gives electron, they become anions, and the electron cloud becomes more bigger. Becomes more bigger. Therefore, the ionic size increases um, down the group and decreases across the period. It decreases across the period. Quickly, we look at another one, which is electronegativity. Electronegativity is the ability of an atom to attract electrons. The ability of an atom to attract electrons. Electronegativity can also be defined as the measure of attraction of an atom for bonding electrons. The measure of attraction of an atom, or the measure of attraction an atom has for bonding electrons. Of course, please note that fluorine is the most electronegative element. And when you move across a period, the electronegativity will increase. Let's take for instance, will increase down, while down the group it will decrease. Now let's take for instance, metals lose electron easily, therefore they are going to have low electronegative value. But non-metals gain electrons easily, therefore they are going to have what? High electronegative value. So down the group, and electronegativity will decrease, while across the period, electronegativity will increase. Now let's look at a key one, electrical conductivity. Electrical and thermal conductivity. To talk about electrical and thermal conductivity, electrical and thermal conductivity is basically as a result of presence of mobile ions, most especially electrical conductivity. And the metals are known to have mobile ions. Why? Because they lose electron easily. So therefore, and as you increase down the group, the metallic property increases, while across the period, the metallic property will decrease. So electrical and thermal conductivity decreases across the period and increase down the group. The electrical and thermal conductivity increase down the group and decreases across a period. Now note that the electrical and thermal conductivity can also be explained, especially from group 1 to 3, then group 4. When we are looking at between group 1 to 3, which is for metals, electrical and thermal conductivity will increase across the period and decrease down the group, because elements in group 3 show more metallic character than elements in group 2 and group 1 respectively. So in between group 1 and group 3, if you are stating the trends, we say that the electrical and thermal conductivity will increase across the period and decrease down the group. But generally, as you move from metals to non-metal, electrical and thermal conductivity will decrease across a period, then increase down the group. This must be well stated and explained. Now let's look at the summary of the periodic table. Down the group, you can see that atomic radius increases, ionization energy will decrease, ionic size increases, electronegativity decreases. While across the period, atomic radius decreases, ionization energy and electronegativity will increase. Now, we can also show it here. You can see that for ionization energy increasing across the period, electron affinity is also increasing across the period. The non-metallic character is increasing across the period, while the metallic character is decreasing is decreasing in the opposite direction. You have the electron affinity as well in this flow chart. Now, let's look at the special features or properties of the periodic table. Number one is the diagonal relationship. It has been observed that elements that are diagonally placed show similar characteristics. That's generally their diagonal relationship. For instance, we could say lithium and magnesium, they are diagonal, barium and aluminum, then boron and silicon, they have diagonal relationship. What does that mean? They share similar characteristics. One of them, for instance, between lithium and magnesium is that they will react with nitrogen to form nitrites, and they are the ones that react easily with nitrogen. Others will have to occur in a discharge tube for them to react with nitrogen, or some will not even react at all. So these properties of the periodic table where elements are placed diagonally is very, very important, because elements diagonally placed show some resemblance and share some properties together. Another one is the screening or the shielding effect. The screening or the shielding effect. What do we mean by screening effect? Like I've said the other time, well, as you move down the group, especially you observe that the number of shell will increases. That means that the valence electron, let's take potassium for instance again. Potassium is 2881. That means the one, which is the valence electron, is at the fourth shell, while the two that is closer is at the inner and is closer to the nucleus than the one. Well, what this means is that the electrons that are inner, that are closer to the nucleus, will shield the electrons that is outer from interacting with the nucleus. That is what is called the shielding effect. And so what is the impact of this? We can see the impact on the ionization energy, the electron affinity, and the electronegativity values of various atoms. Then what is the trend of shielding effect? It will increase down the group because the more number of shell is when we are having more number of shell. The number of shell is increasing down the group, and it will increase across the period. Why? Because it will decrease. It will increase down the group rather. Sorry, it will increase down the group. The shielding effect will increase down the group, and then of course will decrease across a period. It's increasing down the group because the more further away the electron is, the more the shielding effect. But as you move across the period, because of the effective nuclear charge, because there is no increase in the number of shells, they are not moving further away. So the shielding effect, it will decrease across the period. However, for another one that we have is the effective nuclear charge. The effective nuclear charge is the net force of attraction between outer electrons and the nucleus they surround. Down across the period, it will increase. The effective nuclear charge will increase because there is more interaction. There is increase in the number of electrons in without corresponding increase in the number of shells. So the effective nuclear charge is high across the period, will increase across the period, while we decrease down the group. Okay, let's quickly look at few WAEC questions. WAEC 2019 This is the question. You can do well to quickly look at the question and solve. What's your answer? The answer is C, fluorine. Fluorine, because the fluorine has the highest ionization energy because number one, the effective nuclear charge is increasing across the period. The effective nuclear charge is increasing across the period. So the energy that will be required to remove electron is also increasing. So it will be very difficult to remove electrons from fluorine, which is also the most electronegative element. So the answer there is fluorine. Then the second one, going down group 2 in the periodic table. So we look at group 2 elements of the periodic table. What do you think is your answer? What do you think is your answer? The correct answer to that question is melting and boiling point, which is B. Why is it melting and boiling point? There are physical properties that depend on the strength of the bond between the atoms and the molecules. The melting point will increase because as you are moving down the group, for that group 2, metallic character is increasing. So that means that the metallic bonds of calcium is stronger than that of magnesium. So as the metallic character is increasing in this group 2 that we are talking about, the strength of metallic bond will also increase. Therefore, the melting and boiling points will increase. Then finally, let's look at another question, right? 2022. There is they said ionization energy increases across the period because of what? Ionization energy will increase because of the effective nuclear charge. The effective nuclear charge is increasing across the period. Therefore, ionization energy will also increase. So far we have looked at various trends of the periodic table: ionization energy, electron affinity, electronegativity, atomic and ionic radius. In fact, we have also looked at the melting and boiling points and other special features of the periodic table like shielding effect, effective nuclear charge, and the diagonal relationship. Do well to continue to learn and solve more questions as far as periodic table is concerned. Don't forget that this video is brought to you by Agotha Virtual Learning. Continue to learn chemistry and bye bye.